Hi everybody, I'm Sara Mongile from the Istituto di Tecnologia, and today I want to present to you our work on a cortisol-inspired framework in this validation on the humanoid robot iCub. During a human-human interaction, a matching attachment style leads to lower cortisol level than a mismatching it. This happens because we perceive the interaction with the partner as a pleasure and not as a stressor, and it is an important factor in all kinds of social interaction, but also a crucial factor in human-robot interaction. For this reason, we were wondering, if a robot has his own attachment style, is it the same in human-robot interaction? Can we model cortisol in a robot and use its dynamic to understand participant attachment style during an interaction? A robot with this capability, is it better at adaptive behavior? To reply to this question, we have designed a cortisol-inspired framework consisting of three modules: the perception module that affects the cortisol-inspired module in the selection of an action that is performed with the action module. This framework will be validating on the humanoid robot iCub with two different profiles, inspired by human attachment style, and in the replication of the still phase and the still phase plus touch paradigm. Their paradigm used to elicit the cortisol increase in toddler, and in particular, the results show that the still phase elicit higher cortisol reaction in children than the still phase. Considering other findings in literature on the attachment style, we assume that this is true only for the anxious profile, while for the avoidant profile is the still phase plus touch the most stressful. We have recorded the human stimuli in the simulation of the still phase paradigm, and we have designed the two robot profile to be sensitive to different stimuli. This is reflected in the cortisol reaction after being exposed to the same paradigm. We can see how the anxious profile and the avoidant profile reacted to the same paradigm. And in particular, we can see that the anxious profile show higher cortisol level than the avoidant profile. Moreover, if we consider only the anxious profile and we compare the still phase and the still phase plus touch, we can observe that only the still phase elicit higher cortisol reaction. This is because the touch is perceived by the anxious profile as a comfort, while the absence is a stressor, and this is reflected in the cortisol reactivity. So to summarize, we have designed two robot profiles inspired by human attachment style and their appropriate cortisol reaction. Now, the next step will be a comparative study where we will test our cortisol framework. It will involve a participant into two sessions of free interaction with a toddler robot, one in avoidant and one in anxious profile. And for now, that's all. Thank you.